All right, so we're good to start. This is called Eliminate JavaScript Code Smells. So this is not about code that's broken that needs to be fixed. I have a whole nother talk about, hey, my JavaScript's broken. I don't know what's wrong. How do I figure out how to fix it? So there's a concept of code smells, meaning something just doesn't feel right about my code. It works, but usually, I mean, there's some creativity and artistic ability of doing code, and sometimes you can see that it just doesn't look right. And sometimes we don't know why, and so someone needs to kind of help us along. So that's really the idea of this whole talk. About me real quick, I'm Elijah. I'm a front-end developer. I'm a Christian. I have a family. I have one wife, 3 children. I work at Dave Ramsey, and I work on a free online budgeting tool called EveryDollar. And that's enough about me. So has anyone got Lint? Have you ever heard of JS Lint or JS Hint or things like that? Okay, good. That's Douglas in the background. He created it. He also had a son named Jason, not really, JSON, you know. Anyway, boom. So, to lint or not to lint, that is the question. Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous bugs, or to take arms against JavaScript's bad parts, and by opposing them, end them. So, obviously, William Shakespeare knew about JS Lint a long time ago, and so did Descartes. I lint, therefore I am. But seriously, I'm almost done with the jokes, so, oh, maybe. I can't promise too much. But the agenda is not to talk about things that are easy to lint and that have rules that we've all been aware of for a long time. So the things in JS Lint, I'm pretty much not going to talk about those. I'm going to talk about some things that are easy to lint that have maybe some newer rules that you haven't been aware of in some of the newer tools. We'll briefly talk about those because there aren't many I want to talk about. Most of them are things that are easy to lint, but there are no rules. There's no current rules to check for the things that I think are some smells that we should be aware of. And then lastly, we'll talk about some things that are really hard to lint because they're somewhat subjective. Like in some cases, it might be okay, some maybe not. And it's really hard to detect those because there's so much going on. So that's kind of the agenda. So we're going to start with the convoluted. So I'm a little weird about my names. I try to do alliteration, so they get a little strange. So the first one is the convoluted code smell. I got some pigs in the background. What you'll notice here in the bottom, we have 3 circles that kind of indicate if it's easy to lint, what type of rule it is, if it's a newer one or a fresh one. And I kind of target the code, like here's a beginner level code, kind of medium level, advanced. So if it looks advanced to you and it's above your head and you're like, what in the world? You could always come back to it and maybe try to pick it apart later. I'm trying to hit a lot of different levels because you never know the audience, right? So those circles will come to the left here at the bottom. So when I was a kid, I wanted to learn another language because it just seemed cool to be able to speak in another language and your sister not know what you're talking about. So there's Pig Latin. Has anyone ever heard of Pig Latin? All right, so that's another language. So I wanted to learn it. So with Pig Latin, if it starts with a consonant, you basically move it to the end. So pig would be igpe. Trash would be ashtray, which that's kind of a cool one because it's a real word in both cases. If it starts with a vowel, you don't move it. You just add way to the end. So like egg way, inbox way, things like that. So a couple years ago, I decided on my blog, actually it's more than a couple, I'm not sure how long, maybe 4 or 5 years ago, I guess I thought I knew JavaScript, and I wrote this function to do a conversion of English to Pig Latin. And when I look at it now, it's just so shameful. But, you know, that's where I was at the time. And, you know, we're on a journey of learning. And I'm going to actually talk about that in our keynote, just about our journey and where we're at and how to get better as a developer. But when I look at this now, it's like, wow, I pretty much have to read every line of code to figure out what this does. If there was a bug in this, good luck trying to find it. So the thing is, why does that smell? So we're trying to define why things smell. Well, it smells for a lot of reasons, actually. One, it was just too long. There are way too many statements for your head to get around. It was too deep. I don't know if you noticed, there's like a if and then a for and then another if and a while and just, wow, it's really hard to get your head around that. And too much complexity. And that seems like a subjective term, but there's actually an algorithm that was made back in 1976 by Thomas McCabe called the cyclomatic complexity. Has anyone heard that term? Yeah, so it's been around for a long time. But basically, it's a way to try to measure how complex a piece of code is, like how many if statements, how many logical checks. And we could actually test that in our tooling. So maybe C#, if you have a C# background, there's tools in Visual Studio they could use, but you could also do it in JavaScript as well. So I mentioned JS Lint, which is Douglas Crockford made that. Since then, there's been a fork of JS Lint. The community kind of forked it and made JS Hint, and has all the same rules as Douglas's version, but has some additional rules. And so what they added is a couple of features to JS Hint: max statements, max depth, and max complexity. So you could actually test for these things in your code, in your build system, in your grunt or gulp or whatever you use to do your linting, even integrated in your IDE. ESLint is a newer tool, which I'm going to talk more about. It has all the same rules as JS Hint and JS Lint, but it's pluggable, which is really cool because you can make your own rules for your own company, for your own team, and the community is making rules on top of all the other rules, which is really great. So it has the idea of warnings and errors. Everything's not an error anymore. You could choose if you want it to be a warning, or ignore it, or be a problem. And so all of these support max statements, max depth, and max complexity. So for example, if I set this on my Pig Latin code, it would say, hey, that's way too complex, has a score of 7, has too many statements, and it's too deep. It was like 5 levels deep. But wait, there's more. You could actually set a max length, which I usually ignore, but like how long the line is. You could set the max number of parameters. So maybe if you pass 5 parameters into a function, maybe you decide to pass an object instead with properties on the object. The one I like that only ESLint supports is max nested callbacks. So I don't know if you've ever seen code that has a callback with a callback with a callback, and it looks like this big arrow, or it's really quite hard to get your head around. So you could actually tell it what's the maximum level you want to do. So I like that. So what do you do? So when you find these problems, what do you do? Well, you need to refactor the code, right? But before you do that, you need to write unit tests. Hopefully you have them to begin with, but before you start changing code around, you need to know, did you break existing code that worked? So we actually have unit tests for our Pig Latin converter. You don't really have to read it, but we at least have some tests. And then we start refactoring. So I don't expect you to read this. This is actually an ES6, but it's split out into tons of helper methods, like I have an isValid function, starts with val function, starts with consonant function. It's at least broken up into a lot little smaller pieces than it was before. And our intent is not to pick apart the code, it's just the fact that somehow we need to refactor our code. Our unit tests all still pass, so we're good. So if we look at our stats, we went from a max of 16 statements down to 6. So our functions are much more easy to grasp and to get our head around. Our depth went from 5 levels down to 2. So again, it's a lot easier to get your head around 2 levels of indentation. And the complexity score went from 7 to 3, which is a good sign. A couple things went up. Partially because I was trying to be fancy and put things on one line. My max length went from 65 to 73. I added a parameter, so whoop-de-doo, went from 1 to 2. And I actually had a callback because I was using the map method. I don't know if anyone's used map before, but it's really helpful when you need to use it. So for each smell, I have a list of resources at the end, and I'll give you the link for the slides at the very end. I recommend using ESLint because it does all of the things of all the other tools plus more. And unit test your code. I use Jasmine. You could use Mocha or what else you want to use. All right, the next one. This is kind of self-explanatory, but it's the copy-paste code smell. So imagine your boss says, "Hey, I want these squares that have random colors, and inside I want it to actually say the number of the box," which is very arbitrary and I don't even know why I made it up, but let's assume you wrote this code. Let's make this a little bigger. And let's say you decided not to use jQuery, right? Just heads up, we're not using jQuery. We're using query selector all to grab all the boxes on the screen. Now, just so you know, boxes is not a real array, it's a node list. Node list you can't do a for each on because it's array-like. So you have to do some tricks to treat it like an array. So I'm doing a trick where I'm creating an empty array. I'm using call, passing in boxes as this implicit parameter, and I'm looping over it. So already kind of crazy, but let's just roll with it. I'm using the inner text, and then I looked on Stack Overflow on how to figure out a random color. And so I'm doing this weird bit shifting business. But we got it to work, so yip-de-doo. But then your boss comes and says, now we want circles, and the text color of the circles needs to be random. And you're like, hey, I wrote some code that looked very similar to that. So you pretty much grab it verbatim, make some minor tweaks, and you're good. Now, has anyone ever done this before? No, yeah, so. And of course it wasn't you, it was your buddy on your team, right? And so what happens is you start getting this code repeated throughout your code base. And it was done really well the first time, possibly. But someone might have copied it because they didn't understand it. And that just starts propagating everywhere. And obviously, if you need to change something, you have to go and find all the instances of it. So obviously, we know that's bad. We just copy and paste it. But actually, there's some tools to catch this. It's pretty awesome. There's two of them I'm going to mention. One's JS Inspect. It's a node package. You just install it. You run it against your code base. And so what I did, I took two of the code snippets, put it in two different files. I put code above and below each of them, so it wasn't an exact matchup, because that would be cheating a little bit. And I ran it, and it's like, oh, I found these two pieces of code that were very similar. And it told me what lines, one's in red and one's in green. And it kind of highlighted that for me, which that's kind of neat. But there's another tool called JSCPD. I don't remember what it stands for, but it's a lot of letters. But this one will actually check other languages as well. I think it's maybe JavaScript copy-paste detector or something like that. This will check copy-paste in TypeScript, C#, Ruby, CSS, SCSS. So it's more than just JavaScript detection, which is really great. And again, this found the similar code in both files. And what you could do with both tools is you could tell it how specific do you want the compare algorithm. Because if you get too specific, it might find tons of duplications just because one line looks the same everywhere. So you want to go back just enough where there's a threshold. So you might play with that number a little bit. So I ran these against our code, and I was actually a little nervous to see what would happen. But what it ended up finding, I was pleasantly surprised. The only place it detected the copy-paste was in our transformers. Not like the robots, that save the world, but when the data comes back from Ajax and you massage it a little bit so your app runs against that. And there was some duplication there, but I thought that was probably okay, because we want that to be dynamic, and we want to be able to change that over time, and it might look very similar to other ones. So I felt kind of okay with that. So you might run it against your code, but it might hurt your feelings. So be aware. So what do we do in this case? Well, obviously we refactored just like we did before. The way I'm refactoring this, it doesn't mean this is the way you should do it, but it's just a thought process. So the first thing, I took out the Stack Overflow function. I refactored that into a common function. I'm using ES6 for this. You don't have to. And so I've refactored that, cleaned it up a little bit. And then I decided to take out that weird thing where I had the empty array, and I did a for each, and I was doing the call. So I made a double $sign because it's twice as good as jQuery, and where I pass in a selector, and it does all that weird thing. Now, I'm actually using slice, so it converts a node list to an array, but I'm trying to abstract the weird code away. So yeah, you can kind of ignore that. But now the code here is much cleaner. Like, I use the double $sign, I pass in my selector, I can immediately call for each, and I'm doing that business. We could possibly go one step further, but this is just getting a little crazy at this point. So I'm just going to kind of ignore that. But the idea is you need some tool to be able to detect this smell. And these are some good tools to do that. And again, you could wire those up into your Grunt or Gulp or whatever system that you have, or just run it on the command line. So those are the tools. I have a code pen with some of the code of it working, the circles and stuff. So the next one is the switch statement smell. So here's some code that I consider smelly. Can anyone want to guess why that might smell? There's several reasons, so it's not just one.
If you were to add a new shape, you probably have switch statements in lots of different places, and you have to find all of them to add a shape.
Yeah, so that's a great point. This is very brittle code because if we want to add anything new to it, a new type, we're actually changing existing code. The code worked to begin, and so if you're changing it, you have a possibility of breaking code that used to work. So very, very good point. And there's actually more things we'll talk about in a second. So it violates the OpenClose Principle, which is you're kind of pointing at, which is one of Bob's solid principles. I don't know if you know Uncle Bob. You probably do, knowing the background of this crowd. But it essentially says code should be open for extension but closed for modification. And when I first heard that, I'm like, what in the world does that mean? But it kind of stems back to what I just mentioned. If you have code that already works, you should not really be changing it. You should somehow add to that class or that function or without touching stuff that existed. Because, again, it worked, and let's not break something that worked. But what does that look like in JavaScript? So we're going to take a look at maybe a possible way to look at this problem that's different than the switch statement. So as I said before, and here's an example. I kind of jumped ahead because you exactly knew what the problem was, and most people don't, so that's good. So here we're actually, if we wanted to add a circle type, we're actually changing existing code, and that's what we want to get away from. So a common way to get around this problem is to use the strategy design pattern. So it's one of the gang of four patterns that you might be aware of. So what we're going to do, and it looks a little weird, and I'm not using ES6 modules or CommonJS or required.js, so we could kind of clean this up a little bit, but I'm using this thing called IFI, which you've probably heard of these days. It used to also be called a self-executing anonymous function, but most people call it IFI these days, immediately invoked function expression. But what we're going to do is inside of here, we're going to define our triangle constructor, function constructor, and it will have like a height and width. And off the prototype, we're going to have a get array, or get area. So each of our types will have a get area. And then we'll have this common function called get area, which will go and look off the window to see if that is defined, like if it's triangle or square. It'll double check if it's a constructor function. If it is, it'll new it up, pass in the options, and call it get area. So the API is exactly the same as it was before, but we're doing a little bit of craziness to get this to happen. But the cool thing about this is if you add a new shape, so if we wanted to add a circle, we don't change any of that other code. We add a new file, maybe called circle.js. We put this code in there, and that's all we do. We haven't touched anything, and it will work because we're registering our type on the window. So our circle type is now off the window, and it has a get area. So our API understands calling the get area if it finds a circle. And we can actually add other functionality like get circumference. Like, we don't care about that right now, but we could go ahead and add it for someone else. So the cool thing about this is it's very extensible. We're not touching existing code. It might look a little weird if you're not familiar with it, but that's OK. You could always come back to it or talk to me afterwards. So there are some other smells you might have noticed. There were some magic strings. So anytime you have a switch statement, there are usually these special things that you have to identify. And that's pretty awful. So this is the magic string triangle. So has anyone ever done a typo where they put a lowercase t, or if their spelling is atrocious like mine, I put trimangle or something like that? All the time. So and your code's broken and it takes you like an hour to figure it out, and you're like, oh, I forgot to spell it right. So that would be better not to do that. So one way we could do it is to pull that out into like an object and actually register the types. You're really not getting too much here, although, because they could still technically pass in the string, which might be OK. So this is one way. But another way to think about it is use these shouldn't change at all, so why don't we use const? It's an ES6 thing. So if you were in Creamer's talk, I think yesterday, he talked about const. Something he didn't mention is symbol. There's a new idea of a symbol in ES6. And it's kind of like an enum-ish if you've written Java or C#. It's something that's very unique and you can't replicate it. It's like you have to define, that's a symbol that's very unique. And so what we're going to do is we're going to create a shape type with triangle, and we're going to and it's a const, so we can't change them. And we're going to actually say triangle is a symbol. So the only way for this to work is we have to pass that symbol in. It will match the symbol. It's unique to itself. There's no way to fake it out. So that might be a good option for this, and it reduces that smell quite a bit. So tooling, nope, sorry, no tooling. So this is where ESLint comes in. So I mentioned there's JSLint, JSHint, and now there's ESLint, so it's ECMAScript lint. So Nicholas Zakis from Yahoo, who worked alongside with Crockford years ago, he made this tool. Has all the same rules, but it's pluggable. So I made some new rules to cover the things that I think are smells that don't currently have rules. So I created one called no switch, which might be a little heavy-handed if you have switches, but I wanted to make it. So it pretty much won't let you do switches. But the cool thing, again, with ESLint, you could say this is a warning, not an error. You could tell it what levels you want to check for. So I thought, well, maybe that's a little overbearing. I made a no complex switch. I'm somewhat okay if there's a switch statement as long as the part in the case is very terse, like there's one line, which may be a call out to a function. I just don't want the cases to get out of hand. Typically, when you first write one, it's like, oh, it's simple, one-liners. And then, oh, I need to add another edge case, another, and they start growing, and it's a mess. So maybe use no complex switch case. But let's say you want to put this in your code, and it still feels a little overwhelming. Well, most of these tools, like JSHint and ESLint, have a way to conditionally opt out of certain rules only in certain cases. So at the top of your file, you could possibly say, ignore the no switch for just this file. Or if you don't want to do it for the whole file, you could actually have a little piece of chunk in your code and say, I want to just disable rules right now and then enable them right after. Or if you don't want to disable everything, you can say, I want to disable only the no switch rule within this block, and then I want to enable it back. So you have a lot of control. And there's actually even lines for doing it just on one line, so you don't have to start and stop all the time. And JSLint has these same paradigms as well. So here's some resources for this. Actually, there's a free ebook by Adi Osmani on additional JavaScript design patterns. If you want to learn more about scoping and symbols, do that. Or just learn more about ES6, or ES 2015. It's the new name for it. It's pretty cool. All right, the this abyss smell. So here's some code. It's to brush your teeth. So a person has teeth. Most people do. And we want each tooth has the ability to say if it's clean or not. Here we have a person and we have a brush function and it just goes through and brushes all its teeth. Not a big deal. Does anyone see anything that slightly smells with this code? Other than it's about person and teeth. What? Yes. So this piece right here. I consider that a smell. Now, if you have that in your code and you know exactly why you're doing it and you know all the other ways to do it and you still decided to do it, that's fine. I've had people come up after me and like, what about this? I'm like, it sounds like you know all this, so that's probably fine. But the smell is usually people that do that don't know of any other way to get around it. And that's what I really want to talk about. So it smells because they use that or self or selfie or whatever. Actually, I don't have a selfie stick. I don't know if there's any left over. If there is, I'd love to have one because that's just would make my geekdom go a little bit higher, my geek score. So anyway, the smelly code was that. That stinks. And I have inside of here, I have to use that because that stinks too. So are there other ways to get around this? Yes, there's like 4 or 5 ways to get around this. One is bind. So this is not the jQuery bind that you might have used either now or years ago. This is a bind that's part of ES5, which has been around since i9 in all of the browsers. It's a way to tell a function in JavaScript, like, I want you, the this, when you call this function, the this that you're going to refer to later, I want it to be something else. And so what we're going to do here inside of our function, so this is the function that we want to call when we are looping over our teeth. We actually call it .bind on that function, and we tell it, we want the this inside of here that you're going to use, we want it to be something else. We want it to be the this from the outside. So we kind of want to pull in the this from the outside and have it to use in the inside. It's kind of a weird concept. It looks a little crazy, but it works. And it allows us to use this in here, and we don't have to do the var selfie equals this or whatever. Another way is there's actually a second parameter to the for each method. I didn't know this until recently, and most people I talked to didn't know this. So for each takes, normally we only pass it one thing, the function we want to loop over. But it actually takes a second parameter, which is the thing that it will use for this. It's the context. And so we could just pass this there. We don't have to call bind because that's what the second parameter is for. So that works just fine as well. Or we could use ES6 and use the fat arrow. So the fat arrow essentially just passes this context from the outer scope and passes it into the inner scope. So we don't have to do the second parameter, we don't have to do the bind, it just works, which is pretty cool. But if you go one step further, you're like, wait, why don't I just use functional programming? I just was doing one thing, so why don't I just pass the function I want to run immediately into the for each? Now this mostly works. This will work if my clean function doesn't need the this. But if it needed the this, then I'll have to actually bind this to the clean function. It gets a little gnarly at this point, but anyway, know about these functions, know about the different approaches, and you'll be good. Now, as for tooling, I created a no this reassign, so basically it won't let you assign this to anything else. Now that might seem a little hardcore, but again, you don't have to use the rule. But out of the box, ESLint has a couple other rules which are pretty cool. There's a consistent this, so it's out of the box, I didn't make it. If you ever assign this to something else, it restricts that to be the variable name that or this, and you could customize it to put selfie in there. It won't allow you to assign this to anything else other than those things, like that or self, or you could actually add other things for it to look at. The one that I really like, that's super clever, because so ESLint uses an abstract syntax tree to actually figure all this out, whereas a lot of the other tools just try to figure it out different ways. And so there's a lot of power between if you actually split up the code in an abstract syntax tree, you can do a lot of cool things. So no extra bind. What it will do for you, if you say bind on a function, but then inside that function that gets executed, it never uses the this implicit parameter, it'll say, why did you even bind it? Because you didn't even need it. And so it warns you of those things. So clean up your code. There's no reason to bind something if you never even use the this parameter inside your code. So it's pretty cool. If that didn't make sense, there's a link right to it with some examples. And there's some code. All right, so the crisp concatenation smell. So I consider this smelly, and I've written this before. Just you're trying to build up markup, and you're trying to escape your quotes and use single quotes and double quotes and build up this. I don't know. Has anyone ever done this? I've done it. I don't like it. So it smells because it's a cat that was a convict. Anyway, whatever. It's concatenation. So so there's several ways around this. One, I've used this before. It's really great. It's a tweet-sized JavaScript templating library by Thomas Fuchs. It literally, like, this fits in a tweet. It's so small. It's a real low-level, just templating library where you pass in a string. You use curly braces to indicate the properties, and you pass in your object. So the object just looks at the keys on your object and just shoves them right in. It's using a regular expression. You can kind of ignore all this right here, because if you understand it, you probably have another problem. Anyway, but I've used this in really small jQuery plugins that I didn't want to pull in. I didn't want to do concatenation because it bothers me. But I didn't want to pull in like Lodash or handlebars or some really heavy templating library. Now this obviously won't do loops for you and crazy things, but it's just if you just need something to replace stuff, it was really nice. So an alternative is used ES6 template strings, and if you were in Creamer's talk, you probably saw this. Now the syntax highlighting, it didn't understand ES6, so it ignored the green stuff. But really what you do here is you add $ curly brace, and ES6 that understands, oh, I want you to interpolate. So if you ever did CoffeeScript, has anyone ever done CoffeeScript? Maybe? Okay. It's kind of similar to that. String interpolation, that's what they call it there. But whatever variable is in scope at this time, it'll just shove it right in. So I have an href, an ID, and a text, and I'm passing that into my function, and it will just work. The cool thing about this is it supports multi-lines. Yay! So you don't have to have the pluses and the quotes and all that crazy stuff. You just start your tick, do a carriage return, and your tick, and you're good to go. Now there's a problem. Can anyone see a problem in this? I gave this talk before, and someone actually on the TC39 committee was in the audience. They defined the new version of JavaScript, and they actually talked about this. There's a problem with this code. Think about security. So there's a possibility of cross-site scripting with this particular code, and so they identified as like so he's like, yeah, we talked about this, and anytime you have a templated string with markup, you should probably sanitize it somehow. And so there's the idea of tag template strings, where you could actually, and it looks a little funny, is you right before the tick, you give it a function name, and it will run the stuff through this function, and you can kind of do some cleanup. So really, it's the same code as before. I just added this right here. So behind the scenes, I defined this tag template string. The first parameter is the literals, like the things that are static. For example, href would be static. The only dynamic things are the href, ID, and text. So the literals come through, and then the values are the things that are dynamic, like the ID, the href, and they come in as an array. This is the, so I'm not going to go too much into ES6. But anyway, I loop through them. I do some replacing of certain keys, like less than, greater than, and I replace them with different things. But anyway, it will clean up the code. So there are a lot of alternatives to this, like low dash underscore. If you're doing actually a real single page app, you probably don't have to worry about this. You'll be using Angular or React or Ember. But if you are using something lower level, then some of these other things might be nice. As for tooling, again, there's nothing there. I made this one, and it's way overkill. It's called no complex string concat. It basically doesn't let you concat anything more than one. You can only have 1+, which is a little overkill, I know. But you could probably never use that. But you can make a rule for it. So some resources are that tweet size templating engine, that really small one. I've used that before. There's a free resource of learning ES6 on Babel.js. And there's lots of other books. So the next one's called jQuery inquiry. Has anyone written jQuery before? Okay, most people have. Has anyone ever written something like this? I probably have. Okay. Does anyone guess what smells?
All of them.
All right, so there's a lot of things. The main thing I want to point at, and then we'll refactor it and totally write it a completely different way. But the main thing that it smells about it is there's an extreme chaining. Like it's an awesome feature, but if you go overboard, it's like whoa. Because what jQuery does is it will not tell you if something goes wrong. And so any point along the chain, it just silently fails, and it'll just keep going. And you're like, oh, I want to do this and this, and it's like, sure, I'll let you think you're doing that, but there's nothing to do here. And so it's really hard to debug. So one frame of thought is just to split it out into each line, have it saved back to a variable, and then do one line at a time. That solves the problem because you could at least debug through it and figure out what's going on, but it doesn't really clean up the mess. And so what we're going to do is refactor it. We're going to think a little bit outside the box. It looks completely different than it did before. And we're not really using chaining, which was kind of the smell I was talking about. But I want to think a couple of things differently. Does anyone still use jQuery on day in, day out? OK, good. So these are the things you should think about as you're writing your code. There is a 3-parameter version of on. So on is kind of the hot thing to do, right? There was bind and click and delegate. Not as many people were using that. So on is actually a combination of all of those. If you use the 2-parameter version, it's just like the old bind version. It's actually taking the function, attaching it directly to the elements at hand. If you have a loop, it's attaching it to every single one. The 3-parameter version relies on event delegation. It's more like the delegate method. And so what we're going to do is we're going to use the 3-parameter version, 1, 2, 3. We're going to wire up some listeners to the document. So that's the highest level. So what you're noticing, I didn't mention before, is all the code up here is inside document ready, like everything. My new code, the only piece in document ready is this one right here. Like I'm actually able to execute this code way before document ready ever happens. And it's because I'm delegating to the document. The document is always there. The only thing you can't really do is attach stuff to things in the DOM, like elements that have been created. Now, the document's always there, so I could add listeners to the document anytime I want. So what I'm doing is I'm telling the component, anytime a mouse enter or mouse leaves happen, let me know. So it's not actually executing anything yet, it's just listening for it. So what happens is when I actually mouse enter or mouse leave on the component, it'll say, hey, is anyone listening for this? Nope. I'm going to go to my parent. Is anyone listening for a mouse leave on a component? Nope. And it bubbles all the way up to the document. The document has the registration. And jQuery says, hey, is there anything on there that was listening for a mouse leave or a mouse enter on a component? Yes, I have a function. Let me execute it for you. And so it'll just toggle it. I check the type and turn on or off that class. You can do the same thing with anything else, button clicks. So here I'm listening for clicks on a button. And again, I register it to the document. The only thing I have to really wait for is I'm adding a class to something in the DOM immediately. So I have to wait till it exists before that happens. Anyway, it's just a different way to think about a problem. And again, to realize extreme chaining has a problem because if there's a bug, it's really hard to track down. If you want to know more about this in your code, just come up to me later or sync up with me on Twitter. So both code works just fine, just like it should have worked before, and we're good to go. As for tooling, I have a no complex chaining. Again, it's a little overboard. I wouldn't even recommend using it, but it was fun to make. So there you go. It was more just the concept of thinking outside of the box. All right, I call this one the temperamental code smell. So here we have a set interval, and so what happens here is set interval is typically a problem because when it happens, let me see over here. Let me just run it and we'll see the problem. So there's two things. There's set interval and a set timeout. So set interval, you say run this function every so often, maybe every 3 seconds, run a function. A problem you could have is that function that you're calling could take a lot longer than the interval you set up. It could maybe take 10 seconds, like if it was a really slow process. And so what happens, it kicks off the next process before it finishes the last process, and you start seeing these things that kind of bundle up, like two really long processes are going on at the same time. We should see a start, a long, start, long, start, long. But we're not. They're kind of like getting out of sync. So a common way to get around that is to use set timeout instead of set interval. It's a little weird because you're like, well, why would I do that? But the thing is, what you do is, let's see, here's a long process. We'll start some long process, and we'll have a callback to say when it was done. And when it's done, that's when we call set timeout, which kicks up another set timeout. And you just have this kind of one's waiting for the other one to happen. You kick off another one, and yeah. Anyway, so it's just something just to be aware of. Basically, I try never to use set interval. I always try to call set timeout and manually call it again. There are some rare examples, like when I was at work. Actually, my leader was in the audience when I first gave this talk, and he had just had a pull request to have a set interval. And I was like, of course, that was an exception to the rule. So it was a little awkward, but it's fine. There are cases where if the thing that you're doing, you don't really care how long it takes, you're fine. So now they're all in sync. They're not getting out of sync. That one's not all that important. So this one, a friend of mine came up to me at work, and he's like, hey, I have this code I'm reviewing from someone else, and it just feels weird. There's something about it. And I was writing the code smell talk. It's like, oh, this is great. Let's talk about this. So he had some code that kind of looked like this. He had said this, some function, it passed in data, returned the data, and then there was another one, it passed in the data, returned the data, and it just kept going like that. So it was a learning opportunity for both of us to kind of just go through and think about different ways to solve this problem. So the first one, it's a little repetitive, so we were like, let's talk about some alternatives. Here's one that I didn't really love, but is really nesting all the functions together. At the very inside, I had the data. It returned the data, which is the input to the other one, which is the output was the input to the other one. So that's another way to think about the same problem. We didn't really like the solution. Then we went to, well, maybe we could do a for each and somehow have an array of all the functions. We could loop over the functions, pass in the data, return the data. The next one comes, passes in the data, returns the data. That was a little better, but we still felt a little weird that there was this global information that was being used inside there that was being repeated over and over again. Then we thought to reduce. So there's an interesting thing with reduce where, has anyone ever used reduce before? Okay, not as many. And it looks a little crazy. So reduce is kind of like a for each, but there's this memory that you kind of pass along with it and you could build up. I'm kind of abusing the idea of reduce in this case, but just run with it. So I'm starting with this empty data to begin with. I pass it in, and it remembers what the data was before. and then it will run the function, which is the function that's in my array. I'll run that function, return that new piece of data, which is now inside of the memo of the next item, and it just kind of builds up over time. It's just a different way to think about it. The thing I like about it is I'm not depending on global memory inside of here. It's being passed along within reduce, so I kind of like that a little bit better. It's a little confusing if you've never used reduce before. But again, we were just, it was a time for us to just talk about different things and adding more tools to his tool belt. You know, like maybe this is not the right use case for this, but you know it for later. The last one we talked about is lodash or underscore has this idea of flow. And so you could just pass it a whole bunch of functions and pass it the data, and it will just flow it through the system. And so essentially do all the things I was doing before, but the syntax was kind of nice. Does anyone use underscore or lodash? Okay, I would encourage you to maybe look at lodash. It has all the same features but more. It's faster. It's you could actually download portions of it, just the portions you need for your app and not the whole thing. It's small anyway, but if you only need one function, why have it all? John David Dalton is the author of it, and he works at Microsoft on their IE performance team, or I guess it's now Edge performance. But yeah, it's a really great tool, and he does a real good job of make sure it works with underscore. He runs it against all the unit tests, all of Backbone's unit tests to make sure it's compatible. Anyway, I'd encourage you to look at that. So tooling, I have a no reassign, which is, again, it's kind of heavy. If you keep reassigning the same thing over and over again, it'll kind of warn you. But here, the main thing is just a different way to think about problems. So again, think about for each. Look into reduce if you've never used that before. Actually, you might talk to me if you're interested in that, because most of the examples you'll find online is the same example over and over and over again. It's basically an array of numbers, and we want to add them up. That's pretty much all you'll find. But there's actually some really clever things you could do with reduce. And definitely look at flow and some of the other really cool functions of underscore. So this is the inappropriate intelligence smell. So typically as programmers, we try to write our code very modular, like I'm going to reuse this code, this is going to be awesome. And so here we have a shopping cart. Think of like maybe Amazon or something, and I have a product, a shopping cart. I want to add stuff to the shopping cart. And so I'm going to new up a shopping cart, new up a product, and the product I'm going to say add yourself to the cart. So if we look in the product, it's add to cart. It has this reference to shopping cart, and it will add itself to it. This is somewhat smelly because it's actually tightly coupled. We were trying to make our code modular, but there's a little portion of it that had extra knowledge than it needed. Like it was, I know about this global shopping cart thing, and it probably should not have. So it's smelly because this line right here, it knew about something that probably it should not have known about. So what do we do? Well, there's a couple ways to get around it. One is dependency injection, where we actually pass in our dependencies. Some frameworks do this automatically for us, but we could do this manually. It's not a big deal. Or we could use a message broker, and we'll talk about both of these. So what we could have done is when we newed up our product, we could pass an instance of the shopping cart that we cared about as a second parameter to its constructor function. So up here in the product, we have the name of the thing, and then we pass in, we accept the dependency we want to care about, and we save it off as this variable, like an instance variable. And then here in our add to cart, we use the shopping cart off the object to add it. So what we could do later is in our unit tests, we could pass in a dummy shopping cart, or maybe we have a super shopping cart that we come out with, or we want to split test different shopping carts. We could pass in a different instance here, and the product will know about, will use whatever you pass it. So that's essentially dependency injection on a manual perspective. A message broker is a little differently. Like there's some broker that's kind of a higher level, and it listens for messages going back and forth. So what we could do here is the shopping cart could listen for messages that say, I want to add something to the shopping cart. The product, all it does is publish a message. I want to add something to a shopping cart. So neither of them really know about each other. They just know about some message that they're going to listen to. And then it just works. So when the shopping cart hears that something wants to be added, it calls its own add method, which is probably a better abstraction anyway. To make this a little bit better, it would have been better if we passed in the message broker into both of these, so it didn't rely on a global message broker. But I'll leave that up to your imagination. So tooling, this is so fuzzy. Like, it would be really hard to make a tool to identify this problem, just because there's so much. You could write this code in so many different ways. It would be kind of hard. Now, if it was specific to Angular, there's kind of a way to do things there. You could probably write a tool for that. And actually, at the end, people have made ESLint rules for Angular, for Ember, for Backbone, because each of those frameworks have their own ways of doing things. And it might be a little bit easier to detect best practices for those tools and frameworks. Whereas just globally, like, it's a little bit harder to make those decisions. This one is called the incessant interaction smell. So let's assume we're writing an autocomplete. So it's a widget where you type in a text box, and maybe it goes out and queries the results and shows you some recommendations. So I have an autocomplete on my screen. I add an event listener. There's actually an input type. I could have used other types, but input works. And then let's assume I do an AJAX call and something happens. So the problem with that is it's way too chatty. I'm typing. So imagine it's doing AJAX call for every keystroke. Now, your backend friends will really not like you about this if you're doing AJAX all the time. So it's way too chatty. So there's a couple ways to get around this. One is, like, the first thing I think of, I should throttle that. So let's look at throttling. Underscore and Lodash have this throttle method, which is really nice. You just give it a number, like, I only want you to do this event at most every 500 milliseconds. So I'm typing. Now, I didn't really breathe. I was just typing. So within that several seconds, it made all these AJAX calls. Now, from a usability perspective, this is probably still not appropriate. As a user, I was just typing out my thoughts. I wasn't even to the point where I was ready to look at the output yet. So we're still probably making way too many calls for what we need. So what do? There's actually a debounce method. Now, you might not be aware of this, and for a long time I didn't know about it. It looks the same. I just switch throttle with debounce. I leave the same number. But what this means is wait till I stop seeing this event happen for at least 500 milliseconds. So what that happens is I'm typing. I backspace, typing, pause for 500 milliseconds, one call to AJAX. Then the user gets their feedback. You're not being way too chatty. You're probably being appropriate to what they're looking for. And it's probably a better experience for performance all over around. So I typically first think throttle, but then I usually go back to debounce. Throttle is, if you want to use throttle, it's better for, like, if you're listening to events that happen a lot, but you still want to respond, but slowly, like maybe a scroll event, because that happens a lot. I don't know if you've ever looked at how many times a scroll event happens. But maybe you actually do want to interact with it while they're doing it, but just not so many times. Because sometimes if you wait till they're done scrolling, it might be too late. We used debounce on a project, like we auto-saved. Like, so if people are typing and then they paused for maybe 15 seconds, we would auto-save the results back to the server. So that might be a good way to use that. So again, I would highly encourage you to look at Lodash, throttle, debounce, and there's some things. Anonymous algorithm smell. So this is the code that I said was good in the last slide, but now I'm saying it smells. Awesome. Yep, that's how I roll. So it smells because there's this anonymous function here. I'm not saying anonymous functions are bad. There's some issues with them that you need to be aware of. There are some reasons that it might be good to name your functions instead of rely on anonymous functions all the time. Now, we were so ingrained, especially if you use jQuery a lot, and that's maybe kind of where you started. Pretty much all the examples show using anonymous functions. But they kind of, stack tracing is pretty much dead when you do that. If you ever run into a problem and you're trying to backtrack how something happened, the stack trace is like anonymous function. It's not really helpful to help you figure that. Or performance. If you're trying to do performance profiling and see where all the time is spent, you're like, oh, all the time is spent in this thing that's called anonymous. Yay! So it's really hard to kind of figure that out. Dereferencing is a good reason. I'll show you examples of why to do that. And code reuse. Sometimes if you want to use the same thing over and over again, if it's anonymous, you can't reuse it again. So if you give it a name, you could use it in a couple places. So for example, if I tried to stack trace this particular input, I'm not going to use debounce. I'm just going to use the anonymous function. If I do a profile and take a look at it, good luck to figure out which one was this function, because there's anonymous function here, anonymous function here, and anonymous function here. What you would have to do is expand each one, and imagine there could be so many more. You'd have to expand each one to figure out which one is the thing you actually cared about. And if you wanted to know, it was this one. So, because it's calling the log inside of it. Now, what we could do is if we name our anonymous function, just right here, like we're not even storing off in a variable. We're just giving it a name. Right? Some people didn't even know you could do this. You can actually just put a name right there. What will it'll actually show up in your profile, so it matches. Now, we're not reusing it anywhere. We're just giving it a name so we can actually see it as we're profiling, which is actually kind of cool. Unfortunately, when we put debounce or throttle, which as I said was a best case in the last example, what Lodash and underscore does for you is it's wrapping your function with another function, and it gives it a name that's not very helpful called you. And so if you didn't know that, then you're out of luck. So what you can do is by default, the profile is tree top down, but if you switch that to heavy bottom up, then it actually kind of flips it, and it'll rise up the matches to the top and then have the U underneath. So you still, on the top level, you still see the name that you gave it, even though you're wrapping it with the bounce or throttle. So if you're doing heavy call stacks or profiling, giving it just a name could be helpful. Another reason you might want to do it is dereferencing. So have you ever needed to wire up an event listener and have it happen just one time and then unregister itself? I have. Or maybe an event bus where you want to listen to a message just one time, and then when it happens, you want to unlisten to it. Well, if you give it a name, so here I'm adding up an event listener click. I give it a name, I do something, and immediately I call this remove event listener, and then I have a handle to the thing I added. So what that does is I could say click. There's something wrong with this. Let's see. My demo's breaking. I don't know why. But if I click it, it would say alert one time. I'd close the alert, and I'd click it again, and it wouldn't happen. I'm not sure why this is not working. Oh, well, you get my drift. But I've used that trick many times, especially with event listening, with message buses, or even with jQuery. Now, jQuery actually has a ONE, a one event, and it does the same thing. But again, it's more the bind. It's attaching the function directly to the element. So if you want to do event delegation, you would use this trick. Actually, let me try this real quick. Yeah. I'm so paranoid about talks that I have an offline mode, and it switches. It goes from CodePen if it's online. If I say offline, it uses tests I have locally. So, yay for being prepared. Okay. So the other thing is there's code reuse. So if we actually want to store off some common functionality in a kaboom, I'm sure that's what you want to do. Then in multiple cases, you could reuse that. It's like if I click this button, I want to say kaboom, or if I mouse enter on something, I want to say kaboom. And it's going to reuse the same function both times. I could have put an anonymous function in both cases, but that's a little repetitive. I want to reuse it. So again, this is just, it goes back to good code practices, right? So again, now if you're using ES6 fat arrows, those are anonymous. So you're going to have the issue with the stack traces. I don't know if you can name those. That's a really great question. Thank you, Elijah, for asking. So I should check into that. Well, that was awkward. Okay, so this one's an unconfirmed code smell. So, wow, that's awesome. So, does anyone here, maybe I won't ask this, in your head, raise your hand if you're doing unit testing. And if you're not, or if you've just started, a common issue that will happen, especially if you have a code base that has never had unit tests and you go to add unit tests, you'll run into this issue where, and I've had this happen with myself and many other people I've kind of mentored, where once they try to decide to write unit tests with Jasmine, especially if they put everything in document ready, like in jQuery, they'll write their Jasmine tests, and the tests are too late. It's like, wait, document ready has already happened. I want to test things that happened before that. There's no entry point, and that only happens one time. And so in their setup and teardown, there's no way for them to rerun the code that has already executed on their page. And so it's smelly because everyone's putting everything in the document ready, all their wire ups, all their declares, everything, and there's no way to reference those again. So it makes it really hard to unit test. So there's multiple ways to think about this. These are just some ideas. Maybe only, like in your real app, have a document ready and just have it do one thing, like kick off your app. And then your app has all these different modules or classes, and they have a init method. So now in your unit tests, you would not have this chunk of code. Like that would only be in your app. You would manually choose when you want to init stuff in your JavaScript unit tests. Maybe in your setup, you'd call init. And reserve only this line of code for your real app. So maybe in your index.html, you just have this. But for all your unit tests, delete this line of code, make sure it's not running, and always manually call init. Or maybe you have a constructor function where you new up your applications. Again, this would only be in your app, not your unit tests. When document ready happens, new up your app. That way, this stuff in your unit test, you can new it up whenever you want to create that instance. So it gives you a lot more control. And that's a common problem I see when you try to add unit tests after the fact. And I mean way after the fact. Like I write unit tests. I don't write unit tests first. Shame me maybe. I don't know. I write it very close after, like within the same pull request. Like as I'm thinking of unit testing while I'm doing it. But I just don't write it because sometimes I don't even know what I'm going to do yet, and so I have no idea what test I need to write. I'm just kind of experimenting. But definitely, you should write your tests really close to when you're writing it. If you wait too long, you run into cases like this where you just weren't thinking like, oh, I'm going to run into a problem. All right, this is the last one. This is a little debated, highly debated, controversial. It's the two-way data binding. So Mishko, who is one of the creators of Angular, in a recent YouTube video, you can actually go right to where he says this. As he said, you can set directionality to be two-way binding. That actually seemed to be a good idea until you have a large-scale application. Then it turns out that you have no idea what's going on, and it turns out to be an anti-pattern for large apps. So Angular is awesome. You can build apps really quickly. If you're highly dedicated on what you're doing, you might never have this problem, but it doesn't really force you one way or another. It gives you a lot of freedom, and with freedom comes some challenges. And if you've ever had a bug in an app, especially in Angular or something that has two-way data binding, it's hard to figure out what actually caused the problem. Like, how did I get into this state? Because it's magic. The data's going auto-updating everywhere, and it could be a challenge to figure out what actually caused that. And so so Ember and Angular, they're actually in the 2.0 branches, they're actually kind of going away from this automatic two-way data binding because for large apps, it's actually becoming hard to figure out bugs. And writing code is not most of what we do. Is maintaining and modifying existing code and finding out reasons for bugs is what we really spend a lot of our time in. And that's mostly the frustrating part. So it really smells because it's hard to get your head around problems sometimes because it's so magic. The magic is awesome at the beginning, but it could hurt you later. And again, I've talked to people that haven't had that problem at all. That's great, but just be mindful that it could be an issue. So I use React, and it kind of solves that problem because there's not a two-way data binding. There's just one way, and so it's easier to get my head around a problem because if there's a bug, I knew it happened because it could only happen if the data flowed in a certain way, and so I can write a unit test around that and make sure, like in this state, let's check to make sure the output's right. And so it's just a one-way flow, and it's just over and over and over again, which sounds very inefficient, but they do all these tricks to make it really efficient. And again, all the other frameworks, like yeah, that's a good idea. So the next versions are going to look quite a bit differently than they did before. So some resources, the Flux pattern, React. And again, I'm not saying you have to switch to React, but just be aware of the idea. And look out for the new versions of Angular and Ember. All right, so in conclusion, there are ESLint plugins for lots of other things. So if you're using Angular, pull in the ESLint rules that someone made for Angular, because I'm sure they'll help you enforce best practices and maybe help you get around some of these two-way problems. I'm not sure. I didn't look all the rules. I don't have a lot of experience with Angular. But Ember, so they wrote a lot of plugins for Ember. If you do Backbone, there's plugins for that. I use React, so those apply to what I do on a day-in-and-day basis. And there's tons more. So if you're writing Jasmine, there's ones for Jasmine. So just do an npm search for ESLint-plugin, and tons will show up. So the slides are at bit.ly/js-smells. Feel free to pull those up. If you want more information, I'm on Twitter. I'm kind of on there a lot. And I blog. Thanks for coming. I hope you learned something that was applicable to your daily development. And I'm not sure. I'm pretty much out of time. So thank you for coming. Feel free to see me afterwards. I'm doing a keynote later today, so I might see you there. Thank you.